to the last part of the intermolecular forces. So in this part, okay, we will be discussing about the strength of the van der Waals forces. So the strength of the van der Waals forces actually depends on 3 factors. Okay, so this is where we have in decreasing order of importance. So the first one will be the most important factors, continued by second one and third one, the less important, okay, for the van der Waals forces. Okay, first one is the size of molecule, right? In order for you to determine the strength of the van der Waals forces, first thing first, you need to refer or you need to determine the size of molecule. Okay, so if we have the larger molecular mass or the larger the size, what happened here, we are going to have larger size of electron cloud. So when we have larger electron cloud, what happened to the polarizability? We will be having higher or bigger polarizability. And what happened to the van der Waals? The dispersion forces will increase. So in this example, we have example of the molecules and also their boiling point. Okay, so here, okay, propane is the, sorry, it's not the propane, okay, bromine. Okay, bromine is the largest molecule, or bromine gas is the largest molecule in this example. So what happened to the boiling point? Okay, bromine has the highest boiling point. Okay, why? Because when we have highest boiling point, okay, usually the van der Waals forces is also big, okay, and the polarizability also increase because of the size of electron cloud. And then these are the questions, okay, for you to answer during the class. Okay, we will discuss this one during the class. And then other than that, okay, after the size of the molecule, second most important is the surface area of molecule. Okay, the van der Waals forces also increase with the surface area of the molecule. Okay, and these forces are short range forces. So atoms and molecules must come close together for significant induction of dipoles. Okay, so here the molecular shape affects the strength of London forces. Okay, more compact molecules tend to have lower London forces than longer chain like molecules. So in this we have example of neopentane and also the N-pentane. Okay, both of these molecules are non-polar and they also have the same number of electrons, but okay, the boiling point of the N-pentane is much more bigger than the boiling point of the neopentane. Why this happened? Okay, alright, so this happened because, okay, alright, in the neopentane, okay, the structure of the neopentane itself is compact, okay, compared to the N-pentane, which is longer chain. Okay, so if you have longer chain, more surface area, okay, and the other than that, so when more surface area, more interaction will occur or will happen. And third one is the polarity of the molecules. Okay, for molecules with comparable molecular size, okay, similar molecular sizes and shapes, okay, dispersion forces are usually approximately equal. Okay, and the strength of the van der Waals forces depends on the polarity of the molecules involved. So polar with polar has higher strength of the van der Waals compared to the polar and non-polar, and also non-polar and also non-polar. Okay, so here we have two examples here. We have acetone and ethylene glycol. Okay, so acetone is a polar molecule and it experiences dipole-dipole and also London forces. And the ethylene glycol also has 10 atoms. Okay, and in addition to London dispersion forces, also this ethylene glycol participates in hydrogen bonding. So therefore, the viscosity of ethylene glycol is higher than the viscosity of acetone. Okay, and other than that, the boiling point of ethylene glycol is higher than acetone because why? Because of the presence of hydrogen bonds. So here, this is example of acetone and also ethylene glycol, and they have quite a large gap in terms of boiling point. Acetone is 56, while the boiling point for ethylene glycol is 197 degrees C, and they have a similar relative molecular mass, okay, 58. But okay, because of the presence of the hydrogen bond and also the dispersion forces, or we call it as London dispersion forces, okay, this ethylene glycol has larger boiling point. And then last but not least, for this part, okay, as usual, the summary. Okay, in general, the strength of intermolecular forces increase in this order. Dispersion is less than dipole-dipole, less than hydrogen bond, and also ion dipole. And that dispersion forces operate on all molecules and depend only on molecular mass. Third one, the dipole-dipole operates on polar molecule but compete with dispersion. And the contribution of dipole-dipole forces in polar molecules is usually smaller than dispersion forces. However, if the hydrogen bond is present, it makes a significant contribution to intermolecular interaction between molecules. How to compare the strength of intermolecular interaction? Right? So if we have a similar in weight and also shapes, okay, the differences is due to the different polarity of the molecules. Okay, so we need to determine the polarity, and the higher polarity will have greater intermolecular forces. And second one, let's say the molecules, okay, differ widely in weight, and dispersion forces will determine the strength of intermolecular forces, where the higher molecular weights will have higher intermolecular forces. Okay, so that's all for today. I hope you guys enjoy my video, and please don't forget to like, comment and subscribe to my YouTube channel. So I will see you guys after the mid-semester break. Bye!